Hello and welcome to this continuing professional development program presented by LinkStud PSR. The title of this program is Designing Punching Shear Reinforcement to Eurocode 2, and in it we'll be examining how the introduction of this new code requires us to make significant changes in our approach to PSR design. We'll start with some key background information, looking at how methods of concrete construction have changed since the 1980s, and how the issue of punching shear has driven the development of a wide range of reinforcement solutions. Then we'll turn our attention to Eurocode 2 and highlight how the new code has moved the game on from the now outdated BS 8110 standard. After a short overview of the LinkStud PSR system, we'll turn to the main focus of this program, designing and detailing punching shear reinforcement in line with the new EC2 code. We'll look at all the key design considerations and detailing requirements, and we'll examine the class-leading design support solutions provided by LinkStud PSR, including our unique Design Online program. Finally, we'll move on-site for an overview of installation techniques before closing with a summary of the key points we've covered in the program. But before we move on to our first item, it makes sense for us to give those of you not familiar with LinkStud PSR a top-line view of our business and credentials. LinkStud PSR Limited is a legacy business formed following the 2009 breakup of BRC, a company engaged in the supply of steel reinforcement products for over 100 years. But unlike BRC and other suppliers in the market, we are specialists. Our sole focus is on the design and supply of punching shear reinforcement, and we only design in line with the new Eurocode EC2. In September 2010, after 18 months' work at Cambridge University alongside globally recognised punching shear expert Professor Paul Regan, LinkStud PSR became the only punching shear reinforcement business to secure across-the-board UK CARES accreditation. And unlike most other suppliers, we employ highly qualified structural engineers who work closely with leading academics, such as Professor Kypros Pilakoutas of Sheffield University and Professor Amin Ghali of the University of Calgary. These relationships and our specialist focus enable us to operate at the leading edge of the punching shear field and to produce innovative design support solutions such as the Design Online program. So that's LinkStud PSR in a nutshell. Now let's start the program proper with some background on the evolution of concrete construction. Until the early 1990s, concrete frame construction techniques essentially copied those of timber-framed buildings. So, just like wooden floorboards, a concrete floor was laid between joists which spanned to larger beams or purlins, which in turn spanned between columns. The eureka moment came with the realization that concrete's unique properties allowed it to span in two directions, not just one. Designers were then able to eliminate the need for two beams by incorporating them into a thicker floor containing steel reinforcement, and thus flat slab construction was born. Flat slab construction now dominates the market and is most often seen in residential, retail, mixed-use developments and in structures designed to handle large masses of people, such as hospitals and schools, where there are much higher floor loads in comparison to commercial buildings. Flat slabs are appropriate for most floor situations and are also suitable for structures incorporating irregular column layouts, curved floor shapes, or ramps. The benefits of flat slab construction are now well established. It's a minimum depth solution which gives the architect great flexibility when planning the layout in terms of shape and column positioning. It maximises construction speed, essential for the construction industry where time spent on site is always at a premium. It produces a flat soffit with a clean finish and provides excellent access for the layout of services such as heating vents and plumbing. Flat slabs also provide scope and space for time-saving techniques such as specialist shuttering and floating forms. Unsurprisingly, given all these advantages, flat slab construction is almost always the most economical solution when this technique can be employed. When it comes to design, most methodology has been based around the now outmoded BS 8110 standard. Originally, this featured the empirical method for simple frames and the sub-frame method for more complex buildings. However, the advent of computer-aided design and new software allowed the development of improved design methods, such as the yield line analysis and the finite element analysis. But regardless of the method used, it was recognised that punching shear reinforcement at the columns was almost always going to be required in any structure incorporating a thin flat slab. And while Eurocode 2 brings a significant change which demands a new approach to design, this fundamental position still holds true. So just what is punching shear? The punching shear problem starts when the concrete around the head of a column starts to fail as the supported area exceeds its own capacity to resist the shear forces around a point load. The initial cracks are purely flexural as a result of the slab moving. However, as the cracks become larger, they radiate out from the loaded area. At around 60% of the ultimate load, an incline crack appears within the slab. This creates a truncated cone shape and eventually leads to a massive failure. A classic example of punching shear failure occurred in 1997 at Piper's Row Car Park, Wolverhampton, when 120 tons of concrete slab collapsed, fortunately in the middle of the night when no one was in the affected area. While the failure was actually initiated by corrosion of the structural steel due to lack of concrete cover, the mode of failure was clearly punching shear, as evidenced by the classic truncated cone of concrete left around the column heads. Given the advantages of a thin, flat slab, overcoming the problem of punching shear became a priority. Initial solutions took the rather obvious routes of thickening the entire slab, or thickening it locally above the columns to increase its capacity to resist shear forces. But both techniques significantly increased cost, and some of the other benefits of a thin, flat slab were lost. At this point, the first solution based on supplementary steel reinforcement around column heads was developed. Shear links are C-shaped pieces of reinforced steel that are wired into place around column heads. But while effective in reinforcement terms, the use of shear links is far from time and cost efficient. A key problem is the need for the links to be installed by experienced steel fixers in what is a highly time-consuming process. And once fixed in position, the links are difficult to inspect. Add to that issues with health and safety and construction design and management regulations, and it's no surprise that designers started to look for improved solutions. The main objective was to increase speed of installation, and to that end the first prefabricated PSR solutions were developed. Shear ladders comprise rows of traditional shear links fixed to lacer bars, while shear hoops take the links and prefabricate them into three-dimensional assemblies. These tend to be heavy and cumbersome and often have to be craned into position. They can also prove difficult to feed into the bottom of the main steel reinforcement due to congestion. An alternative prefabricated solution was developed by the American Concrete Institute. Shear stirrups take the form of X, T or L-shaped fabrications depending on where the column is positioned relative to the slab. This solution relies on the concrete to transfer the shear forces within it to each of its arms and out into the slab. However, test data on shear stirrups is limited, and as a result this technique is not widely used in the UK. But while shear links, ladders and hoops were developed under the now outdated BS 8110 standard, shear studs are the only PSR solution developed in line with Eurocode 2 using design methodologies based on the concept of a radial pattern of failure. Shear studs are double-headed hot-forged steel studs available in a wide range of lengths and diameters. They are usually supplied welded to non-structural carrier rails, which are then set in a predetermined position around the column head. Shear studs bring many benefits relative to other PSR solutions. Installation is quick and easy, as is checking and inspection, and there's minimal interference with the main structural steel reinforcement. And delivery time is much reduced when compared to that of the more complex bespoke prefabricated solutions. And critically, stud-based reinforcement is the only PSR solution recognised by CARES, and is the only solution tested and accredited by CARES in line with Eurocode 2. So now let's take a closer look at the new code and examine how it differs from the BS 8110 standard it replaces. Eurocode 2, or EC2, was implemented on the 31st of March 2010 and is much more wide-ranging and far less prescriptive than the BS 8110 standard it replaces. The most significant difference in design terms relates to the basic methodology. Under BS 8110, punching shear reinforcement design was based on the structural area of steel per square metre of loaded area. This is not the case under the new code, so all the old lookup tables and rules of thumb can no longer be applied. Under EC2, PSR design is based on the calculation of shear resistance at three specific perimeters positioned relative to the column face, and we'll cover this in detail in the design section shortly. Another key difference is that under EC2, we're now obliged to consider openings in the slab and different edge conditions. EC2 also allows designers to take advantage of new materials and design techniques. For example, it allows designers to benefit from the use of higher strength concretes and uses cylinder rather than cube strength in calculations, which produces more accurate and reliable results. EC2 also builds in significantly greater safety factors. For instance, it takes a more conservative approach at lower concrete strengths, and it ensures that the contribution from the concrete's inherent shear strength is ignored when the shear steel requirements are being designed. Again, for safety, EC2 introduces an explicitly defined design life and the need to build in additional safety factors if this is exceeded. Crucially, EC2 recognises shear stress as being a failure in a radial pattern, which therefore requires a radial solution. Given their flexibility and the ease of deploying them in a radial pattern, shear studs are now seen as the optimal solution when designing punching shear reinforcement in line with Eurocode 2. But before we move into our main design section, let's take a moment to examine the shear stud product in a little more detail, with an overview of the only stud-based solution to be accredited by CARES to EC2, the LinkStud PSR system. The LinkStud PSR system is founded on premium product quality and leading-edge design capability. In product terms, we only use deform bar supplied by CARES-approved mills. This delivers assured performance and ensures the full traceability of every stud produced. The same cannot be said of studs made from smooth bar, where traceability is likely to be lost once the bundle is broken and the studs dispersed. All our studs are forged to a cross-sectional area ratio of 9:1, which provides improved anchorage of the stud in the surrounding concrete. The studs are welded to the non-structural rails in line with EC2, ensuring that the studs are always correctly placed through the plane of failure. And we offer an extensive range of stud sizes, with lengths of up to 1 metre and diameters of between 10 and 25 millimetres available. This level of choice helps optimise the use of resources and maximises cost efficiency. Finally, the LinkStud PSR system can be installed before or after the main structural reinforcement, so there's no need to build punching shear reinforcement installation time into the critical path. When it comes to design, we've already touched on the quality and experience of our in-house team and our relationships with leading academics in the structural engineering field. As a result, we believe our expertise and experience are second to none, and we aim to share this knowledge with partners and customers alike through a range of design support materials and assets. Alongside the CARES technical approval document, our team has produced an extensive manual on designing punching shear reinforcement to EC2, which is available as a free download from the company website. Of equal value is our unique proprietary Design Online program, which allows designers and engineers to create bespoke PSR designs in real time online, after which they can download design drawings and full calculations. Again, this is available free of charge via the company website, and we'll look in more detail at this innovative program after our main design section. So let's turn now to the specific design considerations and detailing requirements which need to be taken into account when designing punching shear reinforcement in line with Eurocode 2. All the main design considerations and detailing requirements for the LinkStud PSR system are listed in the CARES technical report, also known as the TA7. The main design considerations can be summarised as follows. Eurocode 2 requires that all punching shear reinforcement products are tested in line with the relevant European technical approval. There is no problem incorporating the LinkStud PSR system into structures designed to BS 8110, as the PSR can be safely designed and detailed to EC2. The code also states that all PSR systems should be tested against a design method and proved to function as designed. And finally, PSR systems should provide resistance at least equal to the calculated characteristic resistances. Moving on to detailing requirements, the LinkStud PSR design methodology closely follows the requirements of EC2. As referenced in an earlier section, when adopting a radial pattern of reinforcement, shear resistance calculations are made at varying perimeters positioned relative to the column face. The first of the 3 checkpoints is the face of the loaded area, or column face. This is denoted as U0. The second checkpoint is at the basic control perimeter, which is set at 2D and denoted as U1. And the final checkpoint is at the control perimeter, U out, the point beyond which PSR is not required. Having calculated the shear resistance at these points, the next step is to determine the spacing and positioning of the studs, always bearing in mind the spacing requirements set down in EC2 and the UK National Annex. These state that in a radial pattern, the distance from the face of the loaded area to the first stud should be between 0.3D and 0.5D, and the spacing between subsequent studs on the same rail should be no more than 0.75D. EC2 also requires that the tangential spacing of studs within the basic control perimeter should be no more than 1.5D. The tangential spacing of studs outside the basic control perimeter should be no more than 2D, where that part of the perimeter is assumed to contribute to the shear capacity. In an orthogonal pattern layout, the stud spacing within the basic control perimeter should also be no more than 1.5D. But this leads to more studs than necessary being incorporated into the design. In this layout, the outermost perimeter of punching shear reinforcement should be placed no more than 1.5D within the control perimeter, beyond which PSR is not required. All studs are detailed to be tack welded to the non-structural rail in line with the spacing requirements specified in EC2. The rail ensures the studs are correctly positioned in accordance with the code. EC2 states that where studs are installed top-down, the top of the stud where it's welded to the rail should sit level with the uppermost surface of T1, while the very bottom of the stud should sit level with the lowest point of the B1 bars. And having now covered the main design considerations and requirements in the new code, let's look at how LinkStud PSR's Design Online program helps make the task of designing punching shear reinforcement to EC2 simple and efficient. While LinkStud PSR offers a full design service to customers, we aim to try and provide tools that enable engineers to design punching shear reinforcement independently. To that end, we have developed and launched Design Online, which is the only program that allows users to create bespoke PSR design drawings and download full calculations in real time online. The program is available free of charge to all registered users of the LinkStud PSR website and accessed via the Design Room area. Once logged in, Design Online takes users through a 7-step process during which they input project detail into the required fields. So let's start by quickly running through each of these steps. In step 1, users give their design a title or reference and specify the loaded area shape and edge conditions. Each step has the same look and feel, with data fields to the left and the drawing frame to the right. At the bottom of the page is a progress bar that reminds users what point they have reached and allows them to move backward and forward within the program. When the input fields are completed, users click on Next Step to move forward in the program. At various points, a blue eye symbol denotes where reference information is available to assist users with input detail. By rolling their mouse pointer over this symbol, users reveal a new window containing this information. Step 2 covers the size of the loaded area, in terms of the slab depth and the column size. And Step 3 covers the load itself. You can see that the design drawing develops in the drawing window as inputs are made. In Step 4, users are asked for details on top and bottom cover and the diameter and spacing dimensions of the main reinforcement, while Step 5 requires users to input the dimensions of any openings relevant to the column in question. However, if no openings are present, all fields can be left blank. Step 6 focuses on a range of additional design data. All fields in this step are pre-completed, either with fixed data or with default data that can be amended if required. By clicking on Next Step here, users prompt the program to start the full calculation process. And in Step 7, the results are confirmed and displayed. If the design is successful, the stud and rail specification for the column is listed, and users are invited to save the design to their My Designs area. In this area, all the individual users' designs are saved and listed with full reference information, including the date of design, the title of the design, and the column condition. Users are also provided with a range of actions, the first of which is to request a download of the DXF file containing the design drawing. The second option allows users to download the full calculations related to the design, which are provided in a PDF file. The third, fourth and fifth options allow users to edit the design, request a quote from LinkStud PSR, or to delete the design respectively. It is possible, of course, that the design will fail, and the program makes it very clear to users if this is the case, and lists the errors that have produced the failure. In this instance, users should review the calculations and make the amendments required to produce a successful design. To achieve this, it may be necessary to enter the Advanced Options area available at Step 7. Here, users can make adjustments in respect of the treatment of openings and amend spacing and positioning rules to overcome clashes between the punching shear reinforcement and the main structural reinforcement. In some of these cases, a call to our technical team may be required. At this point, we should make a few specific points about the management of openings. Users should be clear that Design Online is an iterative and not an intelligent design tool. It can only respond to the inputs provided in line with its program. It has not been designed to replace the skill, expertise and judgment of a qualified structural engineer. Under EC2, consideration is required not just in respect of the loaded area, but also in respect of a column's position relative to an edge. With openings in certain locations, this can create dead zones where the concrete within the loaded area is not considered to contribute to the punching shear resistance. In such cases, the PSR might be removed or repositioned. However, in cases where the concrete is judged to contribute to punching shear resistance by virtue of the column position, the studs must be repositioned. Design Online can't make these judgments, so if an engineer or designer is in any doubt, they should pick up the phone to our technical team for advice. So that's Design Online. Now, in our final section, we'll focus in on PSR installation. Having taken great pains to create a successful punching shear reinforcement design, it is of course vital that the studs are positioned correctly when they finally reach the construction site. To this end, each LinkStud PSR carrier rail is labelled with detailed stud and spacing information to ensure easy identification and correct placement. Each label contains the site address, the section of the structure and the specific column that the rail relates to, together with its individual stud specification. In the majority of situations, the rails are simply placed studs down on top of the main T1 reinforcement bars after the main reinforcement and accessories have been installed. The rails are then secured in position, usually with wire, while the concrete is poured. When the rails run parallel to the T1 reinforcement, spacer bars can be welded or wired to the T2 reinforcement to raise the level of the rails to the height they would sit at if placed on top of the T1 bars. Occasionally, the studs will be installed bottom up prior to the installation of the main reinforcement. In these instances, the rails should be laid out according to the design, placed on concrete spacers to ensure correct cover, and nailed to the bottom formwork. Care should be taken to ensure the studs are not displaced during the installation of the main reinforcement. Taken together, these actions ensure that studs remain in the correct position while the concrete is poured. As this quote from a major concrete frame contractor demonstrates, the speed and accuracy of installation that can now be achieved with the state-of-the-art LinkStud PSR system, compared to that offered by a traditional shear link approach, is plain to see. And with that, it's time to summarise the main points we've covered in this CPD programme. The introduction of Eurocode 2 brings some significant changes to the way that punching shear reinforcement is designed. The key factor driving these changes is the acceptance by the code that punching shear occurs in a radial pattern and as such requires a radial reinforcement solution. LinkStud PSR provides the only PSR system with CARES approval to EC2. The use of deformed bar ensures the full traceability of raw materials, and further quality assurance comes with the CARES approved certificates of conformity that are issued with every batch produced. When it comes to design, the in-house expertise at LinkStud PSR and the company's close relationships with leading academics ensures clients enjoy a premium design service and benefit from class-leading design tools such as Design Online. The company's overarching approach is to develop its products and services from the perspective of structural engineers and designers. In summary, the LinkStud PSR system is easy to detail, easy to install, and easy to check. It saves time and money, delivers assured performance, and is manufactured in the UK for speedy delivery. And crucially, the LinkStud PSR system is the only punching shear reinforcement solution to be fully compliant with Eurocode 2 and fully accredited by CARES. And that concludes this CPD programme, Designing Punching Shear Reinforcement to Eurocode 2. If you require any more information, please contact the LinkStud PSR technical team on 08456 528 528 or via technical@linkstudpsr.com. And please visit our website and put the Design Online programme to the test. On behalf of LinkStud PSR, thank you for participating, and goodbye.